Solving rational equations. This is section 2.7 from our text. We're still working with ratios. We're still working with fractions. We're still working with x in the denominator. This is important for us. Hold on to that thought. Don't let that go. The directions here are going to change a little bit, but I don't want us to lose sight of what we've just been doing. So we've been dealing with rational functions like f of x equals x squared minus 4x plus 3 over x. And one of the questions that I've asked you to do with this is find the x-intercept. Well, let's remember that code for x-intercept is a solution. And the way we would do that is we would set the y value equal to 0, x squared minus 4x plus 3 over x. If we multiplied the x over, we would get 0 equals x squared minus 4x plus 3. We would factor because we have a quadratic, x minus 3, x minus 1, and we would get two solutions for our x-intercepts. We would get 1 and 3. We're going to ask a very similar question here, but the directions for this question are just going to be solve. And it's going to be a rational equation. Here's our rational equation. X plus 3 over x equals 4. Now this looks very little like our function f of x. We're not solving for an x-intercept. We're just purely solving. But I do want us to bring back that solve or solution is nearly synonymous with x-intercept. All right. There are several ways to solve an equation like this, and I'm okay if you vary from the method that I'm showing as long as you're getting the right answer. For me, I'm going to subtract the 4 over. I would get x plus 3 over x minus 4. I would compare to 0 here. What I'm going to do is I'm going to create a least common denominator of x, and I'm going to multiply by x over x wherever necessary to create that common denominator. So now every term has a denominator of x. The first term would have a numerator of x squared. The second term would have a numerator of 3. The third of negative 4x. That equals 0. Now all of a sudden we see a problem very similar to where we were in solving for the x-intercepts. We can multiply the x over. If we multiply the x over and reorganize the numerator, we get here, if we factor and solve, we would get two solutions of 1 and 3. All right. One thing that's going to be important here is the ability to plug back in. So if we plugged back in, we would get 1 plus 3 over 1 equals 4. That's going to check out. If we plugged 3 back into our initial equation, we would get 3 plus 3 over 3 equals 4. That's also going to check out. Both of these solutions are correct. They solve our initial equation. They create a true statement. All right. Make sure we're connecting those two sides here. We are definitely moving more towards this right side here in section 2.7, but it should be closely related to section 2.6 with rational functions and the x-intercepts. We're going to try another problem here. The directions are solve. X plus 6 over x minus 5 equals 0. Again, there are multiple ways of solving here. Your call. What I would do is create a common denominator of x minus 5. I'm going to multiply the first term by 1, but hidden in there is an x minus 5 over x minus 5. I've now created a common denominator of x minus 5. I would distribute this x. I would get x squared minus 5x plus 6 equals 0. Multiply the denominator over. When I factor, I get two solutions. I get 2 and I get 3. It's important to check those back with our initial. We would get 2 plus 6 over negative 3. Does that equal 0? Yes. When we plug back in 3 plus 6 over negative 2. Does that equal 0? Yes. Both of my solutions work out, and I'm feeling pretty good about those. The final question that we're going to get into today is slightly more complicated. The directions are still solve. All of these that we're working with have a variable of x, but certainly they could be any variable. 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Again, different ways to go here. My thought process is going to be to set one side to 0. I'm going to do that by subtracting over. It really doesn't matter which way I go with this. In this same line here, when I subtract over, I'm going to factor this denominator. It's going to help me see what the LCD is, the least common denominator. The least common denominator here is x minus 1 times the quantity x minus 3. It's really nice that that worked out for us. Hopefully there's at least some commonality in the future. I would need to multiply my first term by x minus 3 over x minus 3 to get that full denominator. I'm also going to multiply my second term here by x minus 1 over x minus 1. And now all three terms have the common denominator. That common denominator, x minus 1, x minus 3, over, I'll distribute the 2x, I'll get 2x squared minus 6x. I'll distribute the 1, and I'll get x minus 1 minus 2 equals 0. I can clear out my denominator, combine all like terms in my numerator, set that equal to 0. Well, it's already equal to 0. I can factor here. Let's not lose sight of the fact that if this does not factor, we still could use things like the quadratic equation. Right. It does factor into 2x plus 1 and x minus 3. We could set each of those factors equal to 0. 2x would equal negative 1, so x would equal negative 1/2. The other solution, x minus 3 equals 0, so x equals 3. I come up with two solutions, negative 1/2, comma 3. It's getting late. I'm interested in going to bed or finishing up with this quiz or whatever it might be, but I should really make sure I plug back in. That's important here, all right? It's important for all of these, but we're going to see something important here. Plug back in. So I'm going to input negative 1/2 back into my original function. And this is not going to be pretty, but it's going to be worth my while in the end. Plugging negative 1/2 back in for every x value I see in my original piece, I'll get negative 1 over negative 3 over 2 plus 1 over negative 7 over 2 equals 2 over 1/4 plus 2 plus 3. Let's clean this up a little bit. Here I'll get 2/3. Here I'll get negative 2/7. Here I'll get 5/21. When I flip that, I'll get 8/21. Create a common denominator over here. I would get 14 minus 6, and that does indeed equal 8/21. And that was a lot. All right, there was a lot going on there. What we just showed, though, is that negative 1/2 does work. All right, I feel good about my work, but let's still stay strong with this. Let's plug back in 3. 2 times 3, 3 minus 1, 1 over 3 minus 3 equals 2 times over 3 squared minus 4 times 3 plus 3. I get 6 over 2 plus 1 over 0 equals 2 over 9, 12 over 0. This should be a huge, big red flag. What's happening here is we solved for an x value of 3, but this x value of 3 is not a solution. We're going to introduce this word extraneous. Extraneous meaning not relevant. All right, this solution, x equals 3, everything we did was correct, but when we plug back in, this is not a true statement. All right, we get a false statement when we plug back in 3, meaning that x equals 3 is an extraneous solution. My challenge to you is to figure out, why did that happen? Looking back at our initial equation, why did that happen? Could we have figured that out without needing to plug back in? The plugging back in was great because it proved that negative 1/2 did work, but could we have known that 3 didn't work before we plugged back in?